Hi, my name is Claire Walsh, and I'm a Senior Research Fellow working between University College London Mechanical Engineering and the European Synchrotron Radiation Facility. I'm a bioimage analyst, and I'm working on a project funded by the Chan Zuckerberg Initiative called the Human Organ Atlas. The Human Organ Atlas, or the HOA as we call it, is an online database of human organs that have been scanned with a new technique called HIP-CT, Hierarchical Phase-Contrast Tomography. This technique was developed in the past 2 years at the European Synchrotron Radiation Facility. What this technique does is it allows you to scan a whole intact human organ at 20 micrometers per voxel. You can then zoom in to any area of interest down to 1 micrometer per voxel without physically cutting the organ up. What you then have is you have a hierarchical set of images going at higher and higher resolution. This data is all put online into a free open access database with our visualizations and some of our segmentations and analyses. This data is open for anybody anywhere in the world to download, to interact with, and to look at. And this is what we call the Human Organ Atlas. The PaNOSC project was really instrumental in helping us get this atlas off the ground. So the team of PaNOSC helped us in creating our online portal, which I can show you here. So this is the Human Organ Atlas that the PaNOSC team really helped put together, getting all the data uploaded and enabling it to be downloaded in a fast way and to organize the database and the metadata for us. So if we go into our Explore, you can see these are the different donors that we have. So if we click on one of our particular donors, you can see the organs that we have scanned. So for instance, we have the heart, and you can see these are the different scans that we have. We have the low resolution, the middle resolution, and the high resolution. And this data can be downloaded via a fast Globus link by anybody anywhere in the world, and all the metadata is stored here online as well. I think FAIR data is like a linchpin of the new imaging methods. As an image analyst, I think FAIR data is really essential for driving forward the field. For our project, for instance, we are generating so much data, terabytes and terabytes of data, and it's very difficult to be able to look through it all and glean all the information and all the use that you could out of that data. By making it fair, communities from around the world are able to access, to look at the data. It might provide new insights from medics or biologists, and it also helps to just drive our field. It helps to drive our field forwards. And me personally as well, I have a particular interest in machine learning, and having well curated open access data sets are the only way that you can develop robust, generalizable machine learning algorithms, and that other people can benchmark their new networks as they're developed. I think it really is, and hopefully we're expanding the Human Organ Atlas as we speak, and it will become a Human Organ Atlas in health and disease. We're currently putting our whole organ data set for COVID organs, which could have a really big impact. And in the future, we'll put up more different types of diseases with the hope that this could really be helpful for, pushing forwards human medicine and our understanding of disease, and also our understanding of what is the range of normal, which I think is a really interesting question. So I think there's a couple of things on kind of actual technical aspects of bottlenecks. I think having more robust cloud storage that's cheaper and easier to get at is one thing that's quite essential. Having the fast, reliable, high-speed internet connections to get the data up and down to the cloud is really important. I think from a more of a principle point of view, one of the things that I think would really help FAIR data in the community is more of a recognition. It takes a huge amount of time and man hours to curate data sets and put them out like this in a portal like I've just shown you. And that contribution as a research scientist can be quite hard to get recognized. It's hard to publish a paper on a data portal. And that kind of having that kind of recognition that is quantifiable from a research scientist point of view, I think would really help people accept it more, so that if you spent a year creating an amazingly well curated data set, that should get just as much recognition as a year writing an incredible methods paper, for instance. The first question is, why not? And I think that's a really important question, because people might have different motivations for why not. If it's technical barriers, helping them overcome those, there are solutions out there, helping them to access those. If it's an objection on principle, why not? Like, why did you get into science in the first place, if not to share knowledge and share data?